So that's your reading. That's a little longer than some of the other readings, but it should be a fairly fast read. I'm interested to hear your thoughts back. And watch one podcast, and as I'm going to talk about which podcast would probably be a good one to read this or listen to this week. So, okay, PERT and Gantt charts. Now, challenges of devising a schedule. Oh, a lot of what we've talked about so far is how hard it is to estimate how long tasks are going to take. Now stop and think about your requirements documents. Do you really have enough information there to estimate your tasks? And the answer is by and large, no. Yet you're going to have to do it this week. And what you'll probably do is the classic thing of saying, this is what we want to accomplish by the last class period, and we're going to work backwards from there. And say, here's the time it's going to take for each of it. Now, for the purposes of this class, that's fine. For the purposes of the real world, that almost never works well. To start with a deadline and say, we're going to build this, and we still have vague requirements, and it's going to ship by this date. The only way you end up shipping by that date usually is throwing out features wholesale and cutting back, and then sometimes you find yourself with something that's just not worth shipping or going live with. So, again, back to Armor, the more novel your work is, the more you're adding that's new stuff, the harder it is to estimate how long it's going to take. Because you've got actual invention you need to do, you have stuff you need to learn. It's kind of like Cole talking about, yeah, we're going to do blockchain, and we have to learn how to do blockchain. You know, that's
easy.
That's a tar pit, right? It's kind of like, oh yeah, here's this whole new technology that's been kicking around and so on, and we're just going to adapt it for this one semester class. You know, but that's a great way to learn. This class is a great place to do that kind of learning. In the real world, it's kind of like, okay, here are a lot of unknowns, or the known unknowns. Plus, we tend to be optimists, as Brooks says, and DeMarco and Lister will agree. As engineers, it's kind of like, yeah, we can do it. It's just going to take a little effort. Chuck Knutson, in talking about scheduling in the video podcast I'm going to recommend, so it says his rule of thumb is to take his first estimate, double it, and add one. So if I think it's going to take 4 days for me to get this job done, it's actually going to take me 9 days to get it done. And part of the reason for that, and you'll hear this, it's kind of like, you'll hear things like double it and add 10%, or double it and double it again. You'll run across, you'll run across, and engineers will very seriously say this, because it recognizes this is sort of a, without even knowing Armor, it's a way of trying to capture that uncertainty. And say, okay, I think I can do this, but I mean, how many of you have sat down to code something that you thought you knew was going to take you a certain amount of time and found it took you a lot longer? Okay, I rest my case. This is exactly the problem with scheduling. And when you're in a business setting, now for a lot of you that's been personal projects you've worked on. In a business setting, you're dealing with meetings, you're dealing with email, you're dealing with phone calls, you're dealing with, I have to produce this piece of documentation. And it's going to be a problem. Another challenge is thinking through the tasks that you're going to have to get done. This is going to be, trust me, you as teams will earn your billable hours this week. Taking what you've got with the requirements document and trying to break it down into discrete tasks that you can do a 0th order approximation. I think this will take 3 weeks. And then start to figure out how you're going to divvy that up among your actual team members. And what the sequence is going to be and what the dependency is going to be. This is not a trivial task that you have as teams this week. That's what I'm trying to say. You want to identify the critical path. Who can explain what a critical path is? Yes?
It's the path that ultimately decides when the entire project will be done. It's the chain of dependency of tasks that have to precede other tasks.
Yeah. In other words, if you, and we'll talk about this more in a second, but when you have a whole bunch of tasks, what you'll find is I've got this task which has to be done before this task can be done, and it has to be done before this task can be done, and that has to be done before the project's done. And this is the longest path in terms of estimated number of days or weeks. That's your critical path. And what it means is that anything that impacts a critical path impacts your delivery date. So if a task that is on the critical path is late, the whole project is automatically late. If you have other tasks that are not on the critical path, they, in theory, can be late without impacting the actual ship date. Part of the problem is actually identifying the critical path. Other challenge, keeping the schedule up to week, because you're going to continue to revise your requirements and the scope of your project, and that's going to have impact on your schedule. And that schedules tend to be, especially, this is a one semester class. You're under a very tight time frame. It's going to be pretty much linear waterfall. It's not going to represent, we're going to get to, some of you may well do this, and last semester I had teams that were able to say, we're going to do a build as of this date, halfway through the semester. And then 2 weeks after that, we're going to do another build and try to add these features to it. And 2 weeks after that, we're going to try and do another build and try to add these features with it. That is, at least in theory, a more ideal thing, but this is such a compressed schedule, it's hard to pull off. Project management is the name of the podcast. It's long. Chuck's very entertaining. Everything he has here is good, but it's like 2 hours. If you just want to see the stuff about PERT and Gantt charts, on the first, and it's broken up into 2 videos. One's a little over an hour, one's a little less than an hour. Go to the first video and go to 6320. He will start talking about task lists and PERT charts there. Watch to the end of the video, start the second one. About the first 15 or 20 minutes, he's talking about Gantt charts. And in fact, I'm going to call up right now the slides that he, I want to open it. Stop hammering it. The slides that he uses during that podcast. Here we go. Now he talks about, this isn't actually a requirement, but it's not a bad exercise that you may want to do as a team or assign someone on the team to do in the next day or so, which is to take your requirements, identify the tasks that need to be done, give your first your first absolutely no basis in reality guess as to the duration of those tasks, and then dependencies. Now he's just using T1, T2. These are going to be actual identified tasks that you have. I wouldn't worry as much about milestones unless you want to, but the idea is that you're going to take your requirements, say here are the things, big chunks that we're going to have to get done. Here's how long we think it's going to take, and here are the people who are going to have to work on it. And then a PERT chart basically says, let's do a graphical, acyclical directed graph. It starts over there on the left where it says start here. As Chuck's to say, he says, of course we start projects on the 4th of July. And you've got boxes here that indicate, the boxes are tasks, the M's are milestones, which you may or may not care about. And the idea is to show graphically the dependencies. So that, for example, tasks 3 and 6, well, task 3 depends upon task 1, task 6 depends upon both task 1 and task 2, task 9 depends upon 3 and 6, task 7 depends upon task 1, task 5 depends upon 2 and 4. I'm touching my screen here and realizing this does nothing for you whatsoever. I apologize for that. That's just sort of, anyway. So you can see up here the basic idea. I mean, this is a simple concept. It's a simple graphical representation. And then the critical path becomes which of these, when you add up the numbers from start to finish, which is the longest path in duration. In this case, that's where the path happens to be. That happens to be the critical path. So, as per, I'm sorry, your name again?
Dallin?
Dallin. As per Dallin's comment, this is the longest path from start to finish. And it means that all the boxes not on the critical path can, in theory, slip a certain amount at least without impacting it. On the other hand, if they slip too much, guess what happens? You have a new critical path. Yes?
Are you measuring amount of boxes, or are you measuring how much time
Dates.
those add up?
Yeah. So you've got a start date and a finish date, and the only way to get to the finish date is to find the longest path and add up the days involved there. The milestone ovals help in that they have intermediate dates, so it makes it, you're basically doing calculations. If you're doing this all by hand, and you can use whatever tools you want. I mean, you frankly can do this on graph paper. I've done it before. I've done it with Visio. You can do it with spreadsheets. You can do it with Google Docs. But there are actual tools that you can get out there. And if you find a cheap one, a freeware, or something with a nice trial period, you can get it and use it. Whatever you do your PERT chart in has to be in a format that you can capture, at the very least, capture a graphic image of it and post it on your wiki. So the critical path method is basically the longest weighted path from start to finish. This, by the way, when I testified back in June, U.S. District Court back in Manhattan, on a failed SAP project, and this was one of the major elements of my testimony, because the other side, I was testifying on behalf of the client. It was like I said, a failed SAP project. And the other side was trying to say, well, isn't it true that the customer didn't do this perfectly or didn't do that? I said, that doesn't matter. I said, none of that was on the critical path. I said, they could have done, I said, the delays are all right here on what the developer was doing or failing to doing. And this stretched out the project schedule. And none of the issues you're raising even begin to encroach upon that critical path for the project as it actually went forward. Can help you to assess risk and to prioritize resources. As Chuck says in the thing, once you identify the critical path, who you want in there, you want the people who are most likely to get it done. So you get people with expertise in a certain area, you want to assign them, if their tasks are on the critical path, assign them to that. If you have people who are learning and coming up to speed, assign them to tasks where they're using that technology and coming up to speed that are not on the critical path. It just becomes an important risk management technique. Gantt chart. Gantt is not an acronym. PERT actually is an acronym. And we're going to talk about that in a second, like project evaluation reporting technique. Gantt is the last name of the guy who invented this chart. Gantt chart's been around for over 100 years. It's sort of like a PERT chart, except that you have start sequence from top to bottom, and you're tracking chronology from left to right. With the shading that Chuck has on this particular Gantt chart, the blue area is what he calls slack space, which is you have, for example, the very first one, T4. The estimate is that it's going to take 2 weeks to get done, but there's no dependencies on T4 until mid-August. Therefore, you've got about a month of slack space. So, if T4 is not getting done, you don't care that much. On the other hand, if you look at T1, pointing at the screen again, notice that T1 has no slack space. That tells you it's on the critical path. T3, dependent on T1, no slack space, critical path. T9, dependent upon T3, no slack space, critical path. And a lot of Gantt charts, by the way, will actually have vertical lines indicating dependencies. T11, T12. So by looking for stuff with no slack space, you've immediately identified the critical path again. Now, Chuck's examples here, he's got single engineers to single task. However, in the real world, you're going to have people. In some cases, you'll have multiple people assigned to a given task. In some cases, you'll have one person assigned to multiple tasks. And you have to adjust your estimates and your planning accordingly. I don't care that much about this. So let's go back to my chart here. I put a couple links. I'll get this up today after I get back here. A couple of online links that simply talk more both about PERT Gantt charts. If you Google them, you can find all sorts of tutorials. You know, it's very easy. Microsoft Excel is set up to very easily do Gantt charts. PERT charts you can usually do with any kind of drawing app. Here's another example. This is my own example of a PERT chart, which I think is actually more readable than Chuck's. But Chuck's is so it's sort of the same thing here. You have identification of tasks and things that need to be done. You have actual projects that have time in there. This doesn't identify, as drawn here, what the critical path is, but it's, you know, this is something that you guys need to put together this week, as well as, here are two more examples of Gantt charts. This is with a, what tool is this? I think this may be a Google tool of some kind that's being used. And by the way, if you go back to the winter 2017 wiki, there's lots of Gantt PERT charts there. A number of different approaches taken. Feel free to go back and look and see how they did them. Figure that whatever they've got there, it's been resubmitted. They probably got a decent grade on it, so it's a good example of what kind of approach to take. So in this one here, you've got teams. This one here, you've got teams or groups that have responsibility for certain tasks. You've got milestones identified this way. Or, and this next one is sort of, this is classically what I think of when I think of a Gantt chart, which is probably far more detailed than you care to get into. But you've got a task, you've got durations, and this is done with a tool here. A start date, and you've identified some of the dependencies, and here you see where it's got dependencies going down between tasks. I wouldn't worry about doing anything that's complicated, but this is sort of the higher end where you see Gantt charts like this. So again, your assignment is to create both a PERT chart and a Gantt chart. Your PERT chart should identify the critical path. The Gantt chart should somehow tie into your team member or staffing allocation and indicate who's going to be working on which tasks. Don't need to use special software, but you're welcome to use, you know, whatever you can find out there on the internet. And this is something you're going to revise. Again, you've got very simple requirements documents. Your PERT Gantt charts right now are going to be pretty simple. But they should somehow tie back to your requirements. In other words, you may have to go back and, at least from your requirements, identify a set of tasks that you think you're going to need to get done for your MVP or whatever. And then from that, say, okay, let's do it as a PERT chart, let's do it as a Gantt chart. And then we'll go over your PERT Gantt charts next week and talk about it, see what you learned in the process. Any question? And this will be due midnight Saturday. I think everyone's reached the, can we just go to team meeting now stage? If there's no questions, I'm done for the day. I'll hang out here for a while. If you have anything one-on-one you want to ask me, I will get the